Assalamualaikum and greetings to all viewers. We are from Section 2, course named Discrete Mathematics. We'll be presenting to you our case study entitled Laying Telecommunication Cable Around the Housing Area. So the leaders of the group is myself, Muhammad Arif Aiman bin Mazlan, with matrix number AA200011, accompanied with my fellow members, Intan Nur Fatihah binti Sa'ari, AA200735, Siti Haja Munirah binti Kamaruzaman, AA200193, Nur Afza Afrina binti Usli, AA201145, Shazwan bin Suhailan, AA201187, Syed Muhammad Afiq bin Muhammad Masuho, AA201147, and last but not least, Muhammad Firdaus Muhammad Sapri, AA201284. As for the contents of the presentation, we'll be highlighting first, introductions of the group member, problems that we face, graph construct, describing vertices and edge, and last but not least, the solution of the problem. For more in-depth of our roles in our team, I'll be going through introduction of our group members. So for task introduction and problem statement, the role was taken by Intan Fatihah. For project methodology task, the role was taken by Siti Haja Munirah. Next, prepare the props or pictures for the project. The roles was taken by Shazwan and Syed Muhammad Afiq. For video presentation, the role was taken by me, myself, Muhammad Arif Aiman. And last but not least, our special video editor, the role was taken by Muhammad Firdaus. For the problem statement, we have analyzed and determined three major problems that need to be overcome. First, the connections of the telecommunication wire from one house to the telecommunication domain is not efficient because it will consume a lot of electricity and it will cause a high cost electric bill. Second, some house might get a late reception, especially the house that is far from the telecommunication domain located, and some houses that are close to the telecommunication domain location will get a faster reception. So the speed reception for every house is not equals or balanced. And third, if the domain locations of the telecommunication has a troubleshoot, then every house that connects to it will get a failure of electric power supply. When this event occurs, there will be a lot of maintenance that the worker need to do. Next, we'll be looking into graph construct and describe vertices and edge. As you can see in the diagram above, we have laid out several nodes or vertices to represent houses and one specifically to represent the telecommunication domain. We have 8 vertices or nodes across the image, which is 1, 2, 3, 4, 5, 6, 7, and 8 respectively. So how it will turn out to be a graph, we'll be laying out edge, which is connection between 2 nodes that will represent the telecommunication wire. So all the edge on the image represent the possibilities of the wire to go from one node to another. Lastly, a weight is implanted to the image. So weight will be representing the distance between one node to another, which is equals to the length of the telecommunication wire. So from this image alone, we finally get what we call undirected weighted graph. So from here, we'll be solving our problems using diff graphs specifically. Next, we'll be going into the solution. So, to find the solutions of this very specific problem, we must first identify what we must do from here till the end. To find the answer, we need first to examine the graph and choose what we need to do. And what we need to do right now is to make a spanning tree. So what is a spanning tree? So a spanning tree model is which the sum of the weight of all the edges is as small as possible. So we want the number of all the possibilities, the lines, which is the edge, need to be as small as they can be, connected to each node. Thus, from the spanning tree, we'll be using what we call prism algorithm. So a prism algorithm is an algorithm that finds a minimum spanning tree for a connected weighted undirected graph. So how do we construct a prism algorithm? First, pick a vertex as a starting vertex. Call it A, or any word or phrases that you will like to use. Second, find the edge with smallest weight incident to A. Color the edge to the next vertex. Call it a B, or any other phrases rather than the first one. Third step, find the edge of the smallest weight incident to either A or B. Call it vertex C. Then repeat the step by choosing the edge of smaller weight that does not form a cycle until it spans all the vertices. The result subgraph is a minimum spanning tree. So let us look into our graph. So to perform a prism algorithm, we need to choose a point, first thing first, as our starting point. So for this graph, we'll be choosing point 3 as our starting point. As you can see, there's a single edge that connected to point 3 and point 1, making that's the only choice that we can make. So the first line will be 0.31 with a weight 47. Moving on to the next node, we'll be looking into 0.3 to 0.5. Now there are two edges that connected between 0.3 to 5 and 1 to 5. But we need to examine the weight first, and as you can see, the weight for 0.3 to 0.5 is the least, so that will be our option. So the second line will be 0.35 with weight 23. Next, we'll be going into 0.2. So there are 4 ways to connect. There are 5 ways to connect to 0.2, but the least weight that an edge connected from one point to another, which is 0.5 to 2, is 32, which is the least number out of all weight that connect to the 0.2. So that will be our next line, which is 0.25 with weight 32. Next, to connect to the next node, which is 0.4, we'll be connecting to it through 0.2, which have the least weight on the edge. So the next line will be 0.42 with weight 31. Continuing with node 8, there are 3 ways to connect to node 8, but the least one will be from node 4. So the next line will be 0.48 with weight 29. Moving on to the next node, which is node 6, there are 3 ways to connect to it, but the least one is from node 1, which have the weight 54. So the next line will be 0.61 with weight 54. And the last but not least, the last point, which is the last node, 0.7. So to connect 0.7, there are 4 different ways to connect to it, but the least one will be from 0.3. So the last line of our prism algorithm will be 0.37 with weight 66. Finally, we'll be looking into our final solution. Now that all the vertices have been selected, so the minimum spanning tree will be shown in colored orange on the image. In this case, we'll be counting the weight of the graph. So 23 plus 29 plus 31 plus 32 plus 47 plus 54 plus 66 will be equal to 282 in kilometers. So the total weight that acquired from the whole spanning tree using Prism algorithm is the least number that we can obtain to connect all nodes, which is houses that we're representing using the telecommunication wire or edge. Now it is more cost-saving and efficient to implement in any housing area. So that's all from us. Thank you.